This lesson is going to be talking about lines cut by a transversal. Now there's some things that lots of definitions and lots of things we need to know. So remember that if you have two lines, like S and Q, and they're cut by one line, so one line goes through two separate lines, this line R is called a transversal, and it forms several types of angles. So interior angles mean they are between the two lines that are being cut. So interior angles are all of these in this section right here. Those are all interior angles. So then exterior angles would then be all the ones on the outside, not between the two lines. So these are exterior angles and these are exterior angles. So that's interior angles and exterior angles, just in general. Now if we look at vertical angles are ones that when two lines cross, they form. So 2 and 3 right there are vertical angles. Take a look and notice that there are 1, 2, 3, 4 sets of vertical angles. They're not all congruent, but 2 and 3 are congruent, 1 and 4 are congruent, 6 and 7, and 5 and 8. Those are called vertical angles when they're on opposite sides of these two lines. Corresponding angles refer to when we have a line cut by a transversal, and so this number 1 and number 5 are considered corresponding angles because they are on the same side of the transversal, in this case the left side of the transversal, and on the same side of the top side or the bottom side or the left or the right, however you want to look at it, of S and Q. So they are on the same side, so those are corresponding angles. Again, you're going to have several pairs of corresponding angles. 1 and 5, 3 and 7, 2 and 6, 4 and 8 are called corresponding angles. Now we get a little bit more specific about our interior and exterior angles. So first we just talked about interior angles. Well, now we're going to talk about alternate interior angles. Alternate means opposite sides, opposite. So if we have 3, 4, 5, and 6 are our interior angles, well, 3 and 6 are on opposite sides of the transversal or alternate sides. So those are alternate interior angles. Same thing with 4 and 5. They are alternate interior angles to each other. Then if we look at alternate exterior angles, again, it's alternate and exterior. It kind of gives you a definition of what it's going to be. Alternate exterior angles are when they're on the exterior. So we know 1, 2, 7, and 8 are exterior angles. Well, alternate would mean on opposite sides again. So 1 and 8 are alternate exterior angles because they are on opposite sides or alternate sides of the transversal, but on the exterior of the two lines. And then same side interior angles, you probably guessed it right from the words, but same side interior angles means on the inside of the line, but on the same side. So 3 and 5 are same side interior angles, and 4 and 6 are same side interior angles. So pause the video and make sure you understand those terms if you need to. So let's look at angle relationships here. Which angle relationships are correct? So take a moment and see if you can work through these problems and understand the terminology. All right, take a look and see if you got these right. 1 and 8 are alternate exterior angles, 4 and 6 are same side interior angles, and 3 and 6 are alternate interior angles. 5 and 7 are not vertical angles. 5 and 8 are vertical angles, and 6 and 7 are vertical angles. They have to be like form V's. Like if you have an X, it's the top and the bottom of an X. And 2 and 8 are not corresponding angles because 2 is on the top side of M and 8 is on the bottom side of N, even though they're on the same side. So 2 and 6 would be corresponding and 4 and 8 would be corresponding. All right, so let's look at relationships between angle pairs. Now, when they're parallel lines, now we're going to look at specific situations. If we have parallel lines cut by a transversal, so these, remember, little lines denote parallel, they have special relationships. Corresponding alternate interior and exterior angles are going to be congruent. That's our special relationship. So if you have a pair of corresponding angles like 3 and 7, they are congruent. If you have alternate interior angles like 4 and 5, they are congruent. If you have alternate exterior angles like 1 and 8, they are congruent. So that's when their lines are parallel, these all have special relations. The same side interior angles is a little bit different. This is the one you're going to have to remember is different, but it will make sense once we go through this. Is if we have two same side interior angles like 3 and 5, well, they're on the same side. Well, we know 3 and 7 are congruent, and 1 and 5 are congruent, and those two form 180 degrees. So the same side interior angles, measure of angle 3 plus the measure of angle 5 is equal to 180 degrees, or a straight line. So those inside angles, same side interior angles, are going to equal 180. The other corresponding, the alternate interior and alternate exterior, are congruent. So let's walk through this little proof. This is going to just to help you in your homework so you kind of understand how this is, how you can prove. A proof is when there's different types of proof. This is a proof where you make a statement and then you give a reason. So we're given a couple of things, the parallel and the transversal. So we know angle 4 is congruent to angle 1 because of, and that is the vertical angles theorem. What we know, vertical angles are congruent. So 1 and 4 are congruent because of vertical angles. 1 and 5 are congruent because of corresponding angles. The corresponding angles are theorem. And then this transitive property, 4, now we can say 4 is congruent to 5, is because of the transitive property. If 4 is congruent to 1 and 1 is congruent to 5, then you can say 4 is congruent to 5. This transitive property is used a lot of times in these types of proofs because we're proving a couple of different angles and then proving a third type here. So here's just pause the video if you want to write this down. Remember, supplementary means equals 180 degrees. So let's find missing angle measures. So now let's apply this. What do we do? So this is just an example of parking lots were created by parallel lines. And we notice we've got a transversal right here and 2 parallel lines. Remember, these little hash marks kind of denote those 2 lines are parallel. So if measure of angle 2 is equal to 115, what is the measure of angle 1? Well, what do we know? Well, these are parallel lines, and here's a transversal, so 1 and 2 are same side interior angles. So we know same side interior. And what do we know about same side interior? We know they add up to equal 180 degrees. So I have angle 1, the measure of angle 1 plus 115 is equal to 180. So all I have to do is subtract 115 from both sides, and I get the measure of angle 1 is equal to 65 degrees. And you can add those up, 5, and get that. So that's an application of this. So now let's look at this. Now you've got to look careful. We've got lots of angles here, and we've got 2 lines and 2 lines. So there's these 2 are parallel, and Z and Y are both transversals. Okay, but it doesn't say Z and Y are parallel. So all we know is that X and Y, W are parallel, and Z and Y are transversal. So the measure of angle 2, well, the measure of angle 2 is over here, and we have one measure is 75 degrees right there. So how do we find the measure of angle 2? Well, what relationship do those have? Those are alternate. They're on alternate sides of the transversal, and they are inside the parallel line. So those are alternate interior angles. So they should be congruent. So they should both be 75 degrees. Now, once that we know that measure of angle 2 is 75, how are we going to find the measure of angle 1? Well, 1 and 2 form a straight line. And what do you know about straight lines? We know straight lines are supplementary, or they add up to equal 180 degrees. So again, we're going to do our same thing. 75 plus angle, the measure of angle 1 is equal to 180 degrees. Subtract 75 from both sides. So the measure of angle 1 is equal to 105 degrees. Now, by knowing one angle in this whole set right here, we can find out every single one of those angle measures, because we know that these lines are parallel. So 75, and I can just go through and I'm going to circle in red all the ones that are 105 degrees. And I'm going to circle in blue all the ones that are 75 degrees. And how do we know that? Well, we know vertical angles are equal. We know alternate exterior angles are equal, or alternate interior, which are those and those, and vertical angles. We also know alternate exterior angles are equal. We know corresponding angles are equal. So once you know one angle measurement with parallel lines and one transversal, we can find out every single one of those angles. Can we find out any over here? Right now we can't, because we don't know that these 2 lines are parallel. So until we're given a number over here or a measurement, we cannot tell if those are parallel or what the angles are. So let's take it a little bit further. So we have the measure of angle 3, which is right down here, is equal to 3x plus 4 degrees. And the measure of angle 5, this one right here, is 2x plus 11. Well, what do we know about those two angles? We know that they are supplementary, right? Because they are same side interior angles. So the equation, what's going to be our equation? Well, we're just going to take those and add them together, and we're going to get 180 degrees. So now we need to solve for x. So, goodness gracious, I'm so sorry. Keep hitting that. So this is the equation right here that's going to go up here. So if we do combine like terms, we get 5x plus 15 equals 180. Subtract 15 from both sides, 5x equals 165. Divide by 5. So we get x equals 33, I think. Now, does that answer our question? No, we're asking for the measure of angle 5. So once we know x is 33, we put it back into here. And so we have 2 times 33 plus 11. So that's 66 plus 11. So measure of angle 5 is actually 77 degrees. So make sure you're answering the question that's asking. All right, pause the video and see if you can. This one's just asking for a value of x. So see if you can do this one. All right, check your work. You should have found that the value of x is 75 degrees. These are same side interior, so we put them, add them together, set them equal to 180, and solve for x. All right, here's a proof. Let's walk through this. So we're given P and Q are parallel, and R is a transversal, and we want to prove 2 and 7. We want to prove our alternate exterior angles. Well, we're given this, we know that, then we're going to say our reason is vertical angles. So which statement says vertical angles? We have a lot of vertical angles here, but which ones are we going to be looking at? And we have corresponding. So I'm going to say, well, I want to get 2 equal to 7. Well, I know 2 and 3 are vertical angles. So my first step is going to be to say that those are vertical angles. And then I'm going to say 3 and 7 are congruent angles. And then notice here's our transitive property. 2 is congruent to 7. So you kind of have to look at the vertical angles are congruent, but which vertical angles do you want to? And then corresponding angles to get your 2 and 7. All right, pause this and see if you can answer this question. Okay, you should have noticed we have parallel lines, a transversal, and these are on the same side and inside the parallel lines. So they are supplementary, they're same side, so angle A is 55 degrees. So in this diagram, measure of angle 3 is 120, and measuring of angle 12 is 80. Now here's another one where we have these two lines are parallel, and then they're cut by two different transversals. But you can find out, because we have an angle in this transversal and an angle on this transversal, we can find out every single one of those angles. So pause and check the ones that are actually correct for this example. If you notice on this transversal, if 3 is 120, then 1 is 60. So every angle in this section is either going to be 120 or 60. So measure of angle 1 is 60, yes, because it's opposite of this to form 180. Measure of angle 13, well, that's not on that one. Measure of angle 6 is right here. It's 80. It has to be either 120 or 60, and it has to be 120 because they're alternate interior. Measure of angle 5 is equal to 60 because those add up to 180 degrees. Now let's look at this next one. Measure of angle 13, opposite alternate interior, so that's 80 degrees is correct. Measure of angle 10 is a supplementary angle. 120 plus 80 does not equal 180, but 12 and 14 are also supplementary, and that equals 100. So hopefully you could follow through that reasoning. Here's another proof. It's a little bit different because it's just written in sentences, but let's just walk through it. If you were given that these are parallel lines cut by a transversal, and we know that 1 and 5, what are 1 and 5? Well, those are corresponding angles, so they are congruent. So their sums are equal by definition of congruent. We also know that by definition, 3 and 1 are a linear pair. A linear pair form a straight line, so they are supplementary by the linear pair postulate. And then by the definition of supplementary angles, measure of angle 3 plus measure of angle 1 equals 180. And then we can substitute in measure of angle 1 for 3. So instead of measure of angle 1 plus measure of angle 5 equals 180, we're going to say measure of angle 3 plus measure of angle 5 equals 180. And there we can say, prove that those are supplementary. Try this one on your own and then come back and check and see how you did. Here's another one where it just kind of walks you through getting 2 and 7 equal. 2 and 5 are vertical angles, so we know vertical angles are congruent. 5 and 7 are congruent because they are corresponding angles. They're on the same side of the parallel lines and the same side of the transversal. And then we can say 2 and 7 by the transitive property. Hopefully that helps you. If you have questions, make sure you ask. Know your terms because they're used a lot in this unit.